Summarizing and Displaying Data, Part 2. In this video we will discuss graphs for categorical data and graphs for quantitative data. So the graphs that we will use for qualitative data is going to be a bar chart and a pie chart. So let's get started with constructing a bar chart. So here we have our data from our eye color, and the eye colors will go along the horizontal axis, and along the vertical axis you can use one of two things. You can either use the frequency or the relative frequency. It doesn't matter which one you use. I'll go ahead and construct using both. Another thing is the eye color data set themselves. There's no ranking on the eye color data set, so it doesn't matter along the horizontal axis which one we put where. In this case, for aesthetic purposes, I think that either going from smallest to largest or largest to smallest is more aesthetically pleasing. So when I construct mine, I'm going to go from largest to smallest. So along the horizontal axis, let's go blue. Then the next one will be black. Then the next one will be hazel. And the next one will be brown. And then over here, along the vertical axis, I'm going to put in the counts. And then we can go ahead and tick mark along the vertical axis 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll just draw a bar to represent the height of these. So there's my bar for the black. I'm sorry, the blue. And then the next one for black is 8. The next one for hazel is 7. And then for the last one is 1. So this is our bar chart for the blue one's kind of skinny, for the eye color data set. Again, to construct the bar chart for using the relative frequency, again we'll do the same thing, but except over here along the vertical axis we'll just put the frequencies. And again, I'm going to put these going from largest to smallest. So down here we'll have blue, then we'll have black, then we'll have hazel, and then we'll have brown. So let's since we're in percentages, I'm going to go 5%, 10, 15, 20, 25, 30, and this will be 35%. So here we have for blue 36%. So we'll draw a bar going up here to 36%. And then for black we have 32%. Then for hazel we have 28%. And then for brown we have 4%. So this would be our bar chart using the relative frequencies for our eye color. So that's it for bar charts regarding our eye color. So let's take a look at our next. When constructing a pie chart, the wedges of the pie chart for each of the variables is allocated by the percentage using the relative frequency and knowing that there is 360 degrees in a circle, we will just take the relative frequency and multiply that by 360. So for example, using our eye color data set, let's just recall that for the black, black was 32%, so we take 0.32 times 360, and this will be about 115 degrees. So 115 degrees will be allocated towards black. For the blue, we have 0.36, multiply that by 360, and that's going to be about 129 degrees. For our brown, we had 0.04, multiply that by 360, and that's going to equal to 14 degrees thereabouts. And finally, for the hazel, we have 0.28, multiply that by 360, and that's going to equal to about 100 degrees, say. So now all we have to do is draw a circle. And again, since we're doing this by hand, all we'll do is approximate these. So for the black, we'll allocate about 115 degrees. So that'll be about right here. Go ahead and label this one black. For the blue, we get about 129 degrees. So that'll be about that much. And then for, let's just jump down to the hazel, we get about 100 degrees. And then finally the last one is our brown. So this is constructing our pie chart for categorical data. The next one we would like to take a look at is displaying data for quantitative data. So here we could talk about histograms, but we'll talk about box and whiskers in another at another point in time, but I'd also like to include another graph called a stem and leaf. And I'd also like to take a look at another plot called a dot plot to represent numerical type data. So using our sibling data set, note that we have constructed this from a previous video, and a histogram is pretty much similar to a box plot, except that the boxes are going to be connected together. So along the horizontal axis, we will put the siblings along the horizontal axis, and as we kind of discussed before, we can either use the frequency or the relative frequency, and the shape of the distribution is going to be the exact same thing. So I'm going to construct using the frequencies, and since we have a single value grouping along the horizontal axis, I'm just going to put 0 through 7, and my maximum count is 14, so we'll break up the vertical axis accordingly. So let's just take a look here. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so that's 10, 1, 2, 3, 4, 5, so that's 15, 10, 5. Okay, so for 0, we had a count of 1. So our bar height here for 0 is going to be 1. And for 1, we had 10. And notice what I'm going to do is I'm just going to center the bars. Okay, we'll just center the bars. on the data value. So we'll go like that. And for number 2, we have 14. So that's going to go just about like this. And for 3, we have a count of 4. So we just go up to a height of 4. And for 4, we have a count of 3. Five, we have a count of 1. 6, 0, so there's no height. And then finally for number 7, we have a graph that looks something like that. So this is our histogram for our data set using the single value grouping. We just put the counts along the y-axis and put the numbers and then center the bars across the numbers. For a limit point, this is going to work exactly the same, except for our limit point, we are going to use the left-hand endpoints all the way up to the end to form our bins. So I am going to come over here then, and we will again draw an X, Y. And here I'm going to start at 56. Then we're going to go 65. Then 74. Then 83. Then 92. And then 101, and then we can take this up to, say, the maximum value of 104. So in this case, I think what I'll do is use the relative frequencies, since on the last one we used the counts. So the relative frequencies here goes from 3.3% all the way up to 33%. So let me come over here to my vertical axis over here, and let's break this up accordingly. So let's just go 5%, 10%, 15%, 20, 25, 30, and then finally 35. So here we'll go up to 33%, so 56 up to 65, 33%. So let's just draw a bar. The next one will be 30%. Then we have 23%. Then we have 10%. And then the last two is at 3%. So here is our histogram for this data set. Okay. Using these, and let's just make an important note here that the left-bound endpoints are always included over here in these bars. Very important to note that. Except for this one at the very end is included in there. So these two guys are included right there. So that's constructing a box and whisker or a histogram when we have the limit, and that is using our cut point grouping, and here I'll just use the classes and the counts for this one. So what I will do is move this over, make a little room, and again to form the to work with the horizontal axis, it's going to work the exact same way. Okay, so again, we're going to use the red ones here. So I'm going to start here at 12, 14, 16, 18, 20, 22, 24, 26, 28. And since we're going to use the frequencies here, we'll just start here. 1, 2, 3, 4, 5, 6, 7. So again, I'll start with 12 and I'll end at 14 with a count of 2. Just like that. This one here will go up to 6. Then we get 7. Then we get 6. 6 again. And then down here to 3. 3. And then down here to 2. Move that out of the way. Okay. So this is our histogram for the fuel tank data set. And again, let's just note that the left end points belong to these bars here. Very important to note that. Okay. All right. A stem and leaf plot is a way of taking the data and breaking the data apart into two components. So let's just take a look at our first digit up here, 56. Notice that 56, I can break 56 into the 50s component and then use the ones component, the 6. So this one here, the 5 and the 50, is known as the stem, and the 6 over here is known as the leaf. Okay? So what we'll do then is we'll take this data set and break it up, and notice that we have 50s, 60s, 70s, 80s, 90s, and then notice here we'll break this up into the 100s. So to construct the stem and leaf plot, again, just break the numbers up. So I'm just going to come over here and go 5, 6, 7, 8, 9, 10. Okay. And notice that in the 5s we only have the 6, so this is read 56. 60s I got 3, so I'll go 1, 2, 3. And then 63s, 64s, and then 8, 9, 9. For the 70s, we go 72, 3, 3, 3, 4, 4, 6, 6, 7, and then 8, 8, 8. Ran out of room. For 8s, for the 80s, we have 3, 7, 9, so we'll just go 3, 7, 9, and then 93, and then 104. So this is a stem and leaf plot for this exam data set. And sometimes when the data set gets too big, using one stem per leaf, which is what we've done here, doesn't show too much information, so sometimes what we have to do is break the stem and leaf plot. So let's just note here that I'm going to now double up my numbers, and let's explain what these mean. So I'm going to go 5, 6, 6, 7, 7, 8, 8, 9, 9, and then 10. I'll I think you'll get the basic gist here. So this first digit here will have the second numbers of 0 through 4, and the second digit here will go 5 to 9. So for our 56, we could just throw a 6 up here. And then here we get 0, 0, 0. And then 3, 3, 3. And then 4, 4, 4. And now notice that these ones here, 8s and the 9s, will go to the next one because they fall between 5 through 9. So we go 8, 9, 9. So now 70s, so we'll go 2, 3, 3, 3, 4, 4, and now we're at 76, so that goes to the next one. 6, 6, 7, 8, 8, 8. And then for the 80s, we got an 83 goes up on this one, and then a 7 and a 9 go on the second one. 93, and really since I don't have anything else, I'm just going to put my 10 right here because we only have one of those. So this is our stem and leaf plot, and notice that this one kind of brings out a little bit more regarding some of the shapes of the distributions when we get to that here in just a moment. Okay. So a third type of plot that we'd like to talk about is a dot plot. So again, using our exam data set, what we'll do is just draw a number line, and then here I'm going to start at, say, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and then 105. So our last one. So then all we do is come to each one of these data points and put a dot. So 56, go about right there. 60, 1, 2, 3. 63, 1, 2, 3. 64, 1, 2, 3. 68, we have only one of those. 69, two of those. 72, 1. 73, we get 3 of those. 74, we get 2 of those. 76, we get 2 of those. 78, I'm sorry, 77, and then 78 we get 3. 83 we get 1. 87 we get 1. 89 we get 1. 93 we get 1, and 104 we get 1. So again, a dot plot is just drawing a real number line and then putting dots at the values, and if there's multiple values, just stack the dots. Distribution shapes. We draw these graphs so we can have to learn about the shape of the distribution, and later on we will discuss why we need to know shapes of the distributions. So one of the shapes that we have is a rectangular, and notice that the rectangular or the uniform shape is just a horizontal line. Here we have a left skewed, so what this means is that the bulk of the data is lying over here to the right, and notice that this thin-tailed over here says we have a few scraggly values over here. The skewness is always associated with the skinny part of the tail, so notice here right skewed, we can identify that because the right part is the thin tail is to the right, and again the bulk of the data is falling right here. And then finally We have a bell-shaped distribution because it kind of looks like a bale. So this looks just like this, where the bulk of the data is falling right here. Okay, so notice another thing is that some of these have humps and some of these don't. So notice that this does not have a hump, and notice that this one does, and this one does, and this one does. These humps are called the modalities, so we will say that this has a single mode. These three here are single modes as well. And one last thing, see if I can't clear some of this off. For a symmetric distribution or a bell-shaped distribution, we can discuss what is called symmetry. And notice that if I draw a line right down the middle here, that the left side and the right side are mirrored images of one another. So a bell-shaped distribution along with a uniform distribution are considered symmetric distributions. And if your data set, if you sketch a graph and it happens to look, something like this, then there's two humps, so this would be bimodal, and anything more than two humps, which would be interesting to see, would be just summarized as multimodal. So let's go back to our histograms that we drew, and again, this is only for qualitative data, and see if we can't identify the shapes of the distributions. Let's take a look at assessing the shape of our sibling data set. And notice that if I was to sketch kind of a smooth curve here over my data set, I would probably find that my curve looks something like that. And here I would probably assess that this graph appears to be skewed to the right. So this appears to be a skewed right distribution. Take a look at our next. And again, if I was to draw a smooth curve here, again, notice we get something that looks like this. And again, here I would say that this appears to be skewed to the right. Look at our next this one here, based off of our stem and leaf plot of the exam data set. Again, notice if I was to sketch a curve, just a nice smooth curve, and then if I was to take this picture and turn it this way, where the numbers are getting larger going this way, again here I would see that this data set appears to be skewed right as well. And looking at our dot plot, again, we can kind of draw a smooth curve here, and this really kind of shows that this is pretty skewed right as well. So that will do it for our video on graphical representations of data sets. I sure hope this video helped you out. Thanks.